The slope deflection equation has four terms in it. The moment at one end is equal to 4ek times the rotation at that near end plus 2ek times the rotation at the far end minus the 6ek times the chord rotation term plus the fixed end moment that's associated with intermember or intramember applied loads. So let's look at the one way to interpret and understand the slope deflection equation, and that is that this member end moment is the sum of four different effects. And if we let some of these be zero and one of them not be zero, we get an interesting understanding of what goes on. So let's let the rotation at one end be zero. We'll have no chord sway, and we'll have no intramember forces, so the fixed end moments are also zero. But we are going to allow the rotation at the near end to be non-zero, and of course for that to happen you have to have some sort of associated moment here at that end, so we'll call that MAB, and that's going to induce a rotation, and that rotation at that end then will create curvatures throughout the beam such that then you end up with a deflected shape that might look something like so. Now the relationship here between this rotation now that happens at this near end, there's your theta A being non-zero, some value, non-zero value, and you get zero rotation at the far end. You have to have a moment in order to prevent that from happening. That's MBA. Now note from the equation that we put, when we're at the near end, MAB, put all these things in there, that MAB is going to be equal to 4ek times theta A. When we go to the far end here, the roles change of near and far, and so it'll turn out that MBA is going to be equal to 2ek theta A. Again, the role of near and far swaps as we swap the location of where we're at, the A's and B's, right? Everything else being held the same. And we're going to do this likewise all the way through the system. We'll come down at the other end, put a positive MBA on there, and now though we're allowing rotation to happen at B, we're not back at A, so that makes theta A 0, theta B is not 0, chord rotation is 0, and again we'll have no intramember loads, so there's no fixed end moment effects. And here then we'll get a deflected shape. Let's not make it too exaggerated here. That will look maybe something like this. And then we gotta get ourselves, I didn't quite get it down far enough here to make a nice good smooth transition. Not too bad there. And there again we'll have a rotation now that has happened over here at B. That's your theta B term. And back here though at MAB, note again, if you really didn't quite believe the whole half relationship we had over here, put in these values 0, 0, 0, and you get then that MAB when the far end is rotated but yet we're keeping it fixed at the left end, meaning no rotation, that will get 2ek theta B from the far end. That does of course mean that MBA is 4ek theta B. Right? We're really just focusing on one end, but notice these are the first two terms in the slope deflection equation. Right? Now we come down to the chord rotation term. We're not going to allow any rotation to happen, but we are going to allow we're going to allow translation, but no rotation. The effect is to have a chord rotation. Chord is just a straight line between 2 points. And that chord term, there's your psi AB, it's going to be equal to whatever this delta sway is divided by the length of the member. Now really it's tangent of delta over L, but the tangent of this angle equals delta over L, but the angles are so small that tangent of the angle is equal to the angle itself in radians. Right, now here we're going to have a symmetric deflected shape, no rotation back here, at the fixed end, and so we'll end up with an deflection point right smack dab in the center. There you go. And the moment now that's associated with that, now physically it has to go into the curve, but from a mathematical standpoint, then I'll show it this way. That's again MAB. It can't actually act that way, so that's why it's the minus 6 EK times the psi term. And then likewise at the far end, it looks odd because we're showing it not the way it's physically acting. That will also be minus 6 EK psi. So there's your first, second, and third terms, and going with no rotations, but our chord rotation is delta over L. And then the final term is the fixed end moment term. Now we're not going to have any rotations and no chord rotation. No, remember, end rotations and no chord rotation. And so now you come along and you have whatever the load is, and then you have whatever the deflected shape might turn out to be. And then let's see if we can't find a way to get a relatively smooth smiley face in here. Not too bad. And there again we've got our member end moments that come from those fixed ends, and so that's your fixed end moment AB would have to be negative in that particular case, and MBA will be your fixed end moment BA. And in another part we'll talk about how you calculate what those fixed end moment terms are.